Okay, welcome to the MSc Advanced Engineering Design program discussion. I'm just going to introduce the program to you and give you an overview of the requirements for entry as well. So my name's Antony Robotham. I'm the program champion for the program and have been instrumental in setting up the program from its particular start. So the program is all about part of the progression towards chartered engineers. And when we look at what a chartered engineer has to do, then there are key things that are very much associated with design activity. So chartered engineer needs to develop solutions to engineering problems using new or existing technologies through innovation, creativity, and change. And these are very much associated with the process of engineering design. Obviously, as a chartered engineer, you would also have technical accountability for complexity of the system and risk within that system. So as far as I'm concerned, the engineering design program does actually enable you to fulfill that requirement of becoming ultimately a chartered engineer. As you know, to become a chartered engineer, you require a sort of bachelor's degree of honours award plus some accredited master's degree award. So what's the MSc Advanced Engineering Design all about? Well, the program has been designed to give you some flexibility to meet your individual needs. So certainly a feature of the program when setting up, there's some choice in some of the modules you do, but also there's a lot of choice in terms of the projects you carry out as part of the coursework on the program. And the important thing is that there is a large dissertation that you carry out, an MSc dissertation that fulfills the program requirements. And that is a topic that you can choose for yourself and direct it to your own ambitions and interests. So its structure is technically we have 180 credits of study at the master's level, and we use a project-based learning approach for most of the work on the taught aspects of the program. And main thing is the program has been designed to fulfill those requirements of becoming a chartered engineer in terms of your educational requirements, but also to prepare you to become professional and competent and workplace ready as an engineering designer. In terms of entry to the course, we require a minimum of a lower second class honours degree at first degree in an engineering discipline. It doesn't necessarily have to be mechanical engineering. It can be something closely related to that sort of discipline. But the main thing is also that I think is you demonstrate an aptitude for design and a desire to actually specialise in the design discipline. And this could be either through the work you've done at undergraduate level or the work experience you previously have coming from your earlier career as an engineer working in industry. Obviously, as an entrant, you'll be wanting to advance your skills and knowledge and understanding of modern engineering design practice, particularly using computer-aided tools. That's both for the design aspects and for the analytical aspects of engineering. And naturally, as I keep referring to, aspiring to become maybe a chartered engineer in the long term. So as a graduate, what will you become? What capabilities will you have? Well, hopefully at the end of the program, you'll have a much more rigorous understanding of engineering design practice. And that's through the methodology that we use to carry out design work, through the tactics and practices that modern industry uses, and of course, through understanding the technical systems and how we can actually describe and prescribe their structure. We'll give you a deeper understanding of computer-aided engineering techniques for both modeling and the analysis of engineering systems. And of course, we'll deepen some of your technical knowledge and aspects of professional practice. Throughout the course, you'll be challenged by doing project work, and that will help you demonstrate sort of innovation and creativity in tackling complex engineering problems. So this is really what you'll come out with, and as a graduate of the program, I hope that you will be able and feel comfortable that you can properly develop solutions to engineering problems and use and demonstrate your capability to innovate in the development of new systems or use existing technologies. And that's a creative process that manages to solve quite challenging everyday problems. What's the structure of the program? Well, the structure is as a full-time student based over 2 semesters, 2 semesters that are taught with 20 credit modules, 3 of those modules each semester. There's a core design theme to the program, as you would expect, with Advanced Engineering Design practice in semester 1, followed by an Advanced Engineering Design project in semester 2. We support your development of research capability and also understanding your personal self-development through a module called Engineering Research Methods and Professional Development. This is something that is taught in semester 1 and enables you to identify the topic for your MSc dissertation. Also in semester 1, you'll be doing more computer engineering, and that will give you the capability to use computer-based technology to analyze the behavior of engineering systems. And then in the second semester, there is some more advanced material technology that you study, and particularly around nanotechnologies and bioengineering products. There is an elective module, and depending upon what modules are available in the portfolio in the school, then you can choose maybe out of 1 or 2 options available for you to fulfill the complete 120 credits of taught study. The biggest block here you see is the MSc dissertation. That is worth 60 credits. And it's a topic that you develop all year. So across the whole year, you start to develop that dissertation project. And then over the summer period, you actually fulfill the whole project, write it up, and present your thesis at the end of the academic year. The academic year for an MSc is 12 months. So it's worth noting that this thesis is delivered usually around September, the middle of September, and the year following your entry to the course. If you were to study part-time, then it's recommended that you do about 40 credits each semester. So these are the modules, and I would suggest you study in your first year of study with us, followed by these 2 modules in the second year that then actually enable you to go and fulfill and complete the program in 2 years, with the MSc dissertation being completed in that second program. This isn't an exact sort of balance. So you do about 80 credits of study in year 1, 40 credits of study in year 2, followed by the 60 credit dissertation in year 2. But that's a proposed study route for part-time study. Just a little bit about those core modules. So in that Advanced Engineering Design practice module, we'll look at developing your understanding of what we call design science. That's the knowledge base around design practice, design thinking, the theory of technical systems, how we describe and understand the actual systems that we are designing. And of course, part of that module will also develop your use of industrial standard computer-aided design tools. So there's a skill set to develop there around computer-aided design. That is followed as the core modules around design of a project-based module in the second semester. And here we utilize all that knowledge by tackling some challenging design problems, both at the detailed design stage, but also at the more conceptual stage, where we challenge you with some quite large and complex grand challenges. The computer-aided engineering module, this is an analytical module that utilizes principally finite element analysis and computational fluid dynamics as tools for understanding the behavior and performance of the engineering systems that you design. So this module very much puts an emphasis upon developing your knowledge of these tools, but most importantly, understanding the actual validation and verification of those simulations to the artifacts you're actually trying to understand. There's a core module again in research. As we said, this is very much introducing to you a methodical way of carrying out research. And though you may not see that you're actually necessarily going on into a research career, the tools and methodologies and approaches used in this module for research, you can apply in your later career for any sort of project development activity. Coupled it to developing your research skills, we also spend some time with you looking at your own personal professional development. So one of the key tasks here is to reflect upon your development to date, how you're gathering your experience as an engineer, how you're achieving the qualifications required ultimately for becoming a registered engineer. And this is an opportunity for you to just reflect upon the experience you've had, the skills that you developed, and plan for how you might address some of those skills necessary to become a registered engineer, but you're yet to fully fulfill. Again, more core modules to the program around advanced materials and engineering. So again, this is going to enhance your current knowledge base around engineering materials. Takes very much a product focus with investigation into product failure, and therefore understanding and identifying design changes to that product that would enhance its capability in the future. Then we've already talked about there being elective models, and for 2021-2022, we have mechanics of marine renewable energy structures and medical engineering biomechanics. These are the two optional modules that you can select on for that academic year. Then a little bit more about the MSc dissertation. This is the sort of icing on the cake. This is what elevates the program to being an MSc, which is this large sort of dissertation type project. And what this does is enable you to select a topic, identify a topic that's very of particular interest to yourself, and so that you can start to immerse yourself in understanding that topic and truly developing a knowledge of how that topic can be evolved and developed, and how that topic can support you in your future career. So the sorts of things that you will do is carry out some sort of substantial research investigation into the topic. And that could be researching into design practice. So it could look at how design actually occurs, looking how design practice currently takes place, and therefore seeing how it may be improved. You might be doing research for design. So you might be creating the database and knowledge base necessary for you to design a product because you don't know enough about, say, its working principles, or it's so novel that you do need to establish some new information and data about it before you can actually design a commercial product. And there's also a feature of design research that says research through design. And this is very much a sort of self-evaluation type research, where through carrying out design practice yourself, you reflect upon your own practices and see how those practices could be improved, or understand how certain aspects of your design practice have achieved certain design goals. And this is very much a self-observation through the practice of design. They're quite interesting themes for design, but gives lots of scope for different types of research project. So study modes, we just already talked very briefly about that, but to sum those up, full-time study is for 180 credits over 12 months, and you have a maximum 3 years to complete the MSc program. And then part-time study is a minimum of 40 credits per year and a maximum of 5 years to complete the MSc program. So those are the sort of study modes that are available to you. And then the actual awards that are available to you, that's the name certificate you'd get. Well, obviously, this award on this program leads to the Master of Science in Advanced Engineering Design, and that's due to you if you achieve 180 credits at level 7. But there are some intermediate awards should for any reason you're not able to complete the program of study, which is postgraduate diploma for 120 credits and postgraduate certificate for 60 credits. These are transferable should you want to use them at some other time in another program. So that's the end of my chat, and open for questions.